I'd like to introduce you to MidsouthMakers Waste Oil Foundry. This foundry is made from an old hot water heater and is fueled by either propane or waste oil and has a shop vac to force air. Now I'm going to tell you how I made this, and I'm also going to tell you what I would do if I were making it again. I'll show some of the pitfalls along the way. First we'll talk about the actual furnace. This furnace is made from a gas hot water heater. In the future I would use an electric one because the gas has a chimney that comes through the center, and you have to cut the chimney out and then seal it. So in the future I'd use an electric hot water heater. They have a smooth bottom and you're able to cast and pour with much less hassle. This was just cut off with a sawzall and a grinding wheel. It is made insulated with refractory. Refractory is a type of castable stone that does not burn. This is high temperature refractory. In the future I would use lower temperature insulating refractory because this has a very high thermal mass and takes a very long time to heat up. So to increase the efficiency of your furnace, use insulating refractory even though it's lower temperature. You can see this is about 1.5 inches in thickness, which is a good thickness. I was able to cast it into here using a cardboard tube as an inner form, and then just pour in the refractory around it. And that worked really well. I don't know any way to improve on that. But as far as the design of this furnace goes, I tried to make a compromise between a foundry and a forge and put in side ports here so that I could feed metal into the side. This was a bad idea. It makes it work less efficiently as a furnace and doesn't work as a forge at all. So in the future, use more traditional designs that don't have these side ports, but instead have a flat rim and a hole in the top here for an exhaust port. Speaking of the top, this top doesn't have the exhaust port in the top. It also doesn't have any reinforcement in the top, so it's very fragile and will probably break sometime soon. But it's also 2 inches of refractory. It's nice and heavy. Unfortunately, these exhaust ports are far too large and let out too much heat, making it inefficient at best. Now, this is the burner for the foundry. This burner is able to use 2 fuels, either oil, which is fed in here, or propane, which is fed in through this tube. Air is supplied through the Harbor Freight shop vac, and it comes in through this arm. Now, in the future, using propane, I would locate this input as far back as I could to let the propane and air mix inside this tube for as much distance as possible. What I experience on this burner is the flame actually leaves the tube and doesn't ignite until several inches away from the mouth. If I can improve on that next time, I will. Now, the furnace has to be heated up before you can use the waste oil. So we use the propane to heat it up, and then we can switch on the waste oil just by turning this shutoff valve. The propane is fed in through a quick attach adapter, which goes to the propane tank, which has a shutoff valve, a regulator, and the tank. Let me just say, this is unsafe. Don't do what I've done, but I'm showing it to you because it is done. The quick attach adapters are known to leak, and leaking propane is a bad sign in an enclosed space. The tube itself here is rated for air. It's an air compressor hose. And the propane could break it down, make it fragile, make it leak, and leaking propane is bad. In the future, I would use copper tubing to do all of this. The other downside of this hose is that it's flammable. If hot metal fell on it, it would melt right through there. Propane would spew out, probably catch fire from all the hot things around, and everyone would run screaming. humorous, but not good. The shop vac that supplies air is powered through this box right here, where I have used a dimmer switch connected to these outlets so that I can control the power of the shop vac. In the future, I would use a router control. It's basically the exact same thing. It's just designed to handle the kind of loads that you might encounter with a shop vac, and it costs less than this. So there's really no downside to it. Go get a router control. You can find them at Harbor Freight for like $19. The waste oil that's fed in here, this hose goes to a 5-gallon bucket that's filled with automotive oil. It's not good to breathe in the automotive oil, so you can see I generally set this up when I'm going to use it outdoors. The design here is very simple. This adapter, it's just a hex plug that plugs up this 1-inch tube, and I just drilled and tapped on both sides of this hex stop an 1/8" NPT thread, so that I can put in the short nipple on this side, and then the other side has a long nipple, so we have a concentric tube inside this tube that feeds oil right to the mouth of the tube. This allows the air to blow the oil into the hot furnace, where it ignites and keeps the furnace hot. It's a really simple method, and it works very well once the furnace is hot. Unfortunately, if you're using this high temperature refractory, it will take a long time for the furnace to get hot. The walls of the furnace need to be glowing before you can feed the waste oil in there, so that the waste oil will auto-ignite. Also, it'd be better if there were a way to better aerate the oil as it went in there. As it is, it drips off the end of the tube, and the air splashes it against the far side of the foundry. It works, but it'd be nice if it would work better. There are some burners I've seen that use compressed air to blow a very fine spray of oil, and that'd be great, but then you'd need an air compressor instead of just a Harbor Freight shop vac. It's not really a hindrance to most people, but I was going for utter simplicity. So that's it. This is the Mid-South Makers Waste Oil Foundry.